Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah rabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. Amma ba'd. A'udzu billahi minasyaitonir rajim. Walau anna ma fil ardi min syajaratin aqlamu wal baghi min ba'di saqatin Abhurim manifest kalimatullah inna Allah azizun hakim. Inshallah today we will continue with our lecture about separation technology, which we will continue our topic, which is membrane separation technology regarding the membrane process. Okay, so this is a part 2, which we already covered some part of our subject on previous week. So for the classification of membrane, we can classify the industrial membrane to four components of membrane, which is reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. So what is the difference between all of these? The difference between all of these membrane is only one, which is the pore size. The pore size of each membrane. For example, here you can say if we have particle in our a lot of particle in our solution. We have larger particle and we have a mixture of a small particle and a tiny particle. So for microfiltration, because for the membrane process to work well, each membrane will have the pore. So it can pass through only a certain element according to their size. So for microfiltration, for example, if you have five different sizes of particle here, it will permeate, or it will allow this four particle to pass through, while for the large particles it will retain for the large particle. And if you go to ultrafiltration, for ultrafiltration we have four particles now, so it will retain the larger particle among them and permeate the rest of the particle according to their size. And it same thing happen to nanofiltration and also reverse osmosis. And if you can see the reverse osmosis, it only allows this smallest particle here. So if we say about membrane processes, it is about how the particle pass through the membrane. So it's about size. So for example, we can see two diagrams here. So here is microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. For example, for microfiltration, so if we have in our solution we have water, monovalent, multivalent, ions, virus, bacteria, suspended solid. So if you have all of this in our solution, so for microfiltration, it will retain the bacteria and suspended solid, while it will allow all the rest of our element to pass through the membrane. We look at the ultrafiltration. So now we have water, monovalent, multivalent element, also as well as we have virus, bacteria, and suspended solid. So for ultrafiltration, it only allow water, monovalent, and multivalent, because this element, if we see the sizes, this element is bigger than the pore of the membrane of ultrafiltration. So the same principle goes to nanofiltration. So for nanofiltration, it only allows the water and monovalent to pass through the membrane, while for the reverse osmosis, it only allows water to pass through the membrane. So here is for the orange arrow, it is the type of material or the type of particle that is be retained by the membrane. So for the left side diagram, it is about is talk about the size of um, each element or each particle. So for example, so for microfiltration, so if we have all of this, it allows to pass or to permeate a certain element while we retain a certain element according to their size. And now let's see about the reverse osmosis. We see before where we have microfiltration, ultrafiltration, ultrafiltration, and reverse osmosis. So the um, the idea is uh, all of the element, all of these particles are able to pass through the membrane. But why the reverse osmosis are only able to permeate or to only able to is only is water is only able to pass through the membrane. So if we go to reverse osmosis, for reverse osmosis filtrate have the pulsar of the reverse osmosis membrane is about 0.0001 micron. It's very small, so that's why it can permeate the water. So if we look at the reverse osmosis, if we go to bottle, if we go to mineral water or drinking water that we see or um, water machine, there is right stated there is RO filtration. So essentially, we only have a pure water in it because this system will remove all most mineral, virus, and also organic molecules. So we only have a pure water without have anything else. So to understand how reverse osmosis work, it is helpful to understand osmosis first. So we learn about the osmosis theory in our secondary school. So what is osmosis stated? Osmosis stated occurs when a semi-permeable membrane spread two salt solution of different concentration. For example, if we have we look at the diagram A, we have fresh water and also water, and so we have semi-permeable membrane here. So because of the concentration of the solution is different here, what it will do, so the fresh water here will move to here. So and then what will be is you can see that the volume of water here will be decreased a little bit because the water here moving to our right hand side. So to make this volume is increases. So this is what we call osmosis. So osmosis is about a different concentration. So the water will move from high concentration to a lower concentration. So it will make sure that the concentration is balanced, or we call it as equilibrium. So the water here will migrate from the weaker solution to the stronger solution until the two solutions are of the same concentration. Because this semi-permeable membrane allow the water to pass through, but not the salt. So it's only allow the water. However, if we look at the reverse reverse osmosis. So what's meant by reverse osmosis? Reverse osmosis, the two solutions are still separated by a semi-permeable membrane, but here pressure is applied here to reverse the natural flow of the water. For natural flow, it will be from fresh water to salt water. However, here the water from the water in the salt concentration, the salt water here will move to here. So the water molecule will be here. So left with only salt. So that's why we say that in reverse osmosis is only content of water. So because the force of the pressure or the force, this force, or we call it as the pressure that we applied before, um, force the water to move from the more concentrated solution to the weaker solution. Thus, the pure water is left in this side. So here is how the reverse osmosis work in if we look at the all the product or our drinking water or any product that we stated that reverse osmosis, that is how it works. So in this part, you can see the the driving force, the separation size range, and also example of separated particle that is being used for all the separation process. For example, if we look at the microfiltration, where the driving force is pressure, so it will separate the particle between 0.1 micrometer, 0.1 micron until 10. So for example of the material separator, it's like a small particle, large colloid, and microbial cell. And so we go to ultrafiltration and filtration and reverse osmosis. It will the size of a particle is become smaller. So here you can see the relative size of various material in water. So that's why if we would like to go to water treatment, it depends on what is our objective. So we can choose a right membrane for our separation process. So we can either it's depend on objective, either we need to use ultrafiltration, or we need to use a reverse osmosis technique, or it just okay with microfiltration. It depends on our objective. So there's a few video in YouTube that I put it in my slide, so you can refer to it to see how uh, all this material is being separated in water treatment. So here you can see the concept of how memory work. You can refer to this YouTube link. So I hope that my lecture on I hope my lecture on this topic will be clear. And if you have any question, just communicate with me through WhatsApp, or just uh, or you just can call me. Thank you for the session.